Inequalities. So this is section 5.3, goal 2 and 3, mainly 2. So inequalities. Inequality is a mathematical sentence that compares quantities that are not equal. So if we actually look at the word inequality, we can see in, which means not, and equality means equal, so not equal. It all makes sense, right? So not equal. So this is a mathematical sentence. So just like an equation, it's going to have two sides to it. It's going to have an answer and a bunch of other things. And it compares things that are not equal. So let's look at this first statement. So the first part of this goal is you need to be able to translate words into an inequality. So let's look at this first one. The DVD costs more than $15. So the DVD, we can create a symbol for that, and we can call it D. It's a variable, and it costs more than $15. So we have $15. And how are we going to show that something is more than? More than. Well, if the DVD is more than $15, we are going to have the symbol, inequality symbol, that is going to show that the D is more. So we can say that this symbol is going to, it'd rather eat more than less. So it'd rather eat the D than the 15. So we can finish this up and we can write it a little smoother as saying D is more than 15. 15 is essentially less, so that's why it has the closed mouth next to it. Whereas D is more, so it has the open mouth, so something wants to eat something that's more. It's always appealing to us humans. The next part. The height requirement for a roller coaster is greater than 40 inches. Greater than or equal to 40 inches. I said it wrong. So the height requirement, we're going to call that H, is greater than or equal to 40 inches. So we also have 40. And how are we going to show greater than or equal to? So you have to be 40 inches or more. You could be 41 inches, but you cannot be less than 40 inches. So we can show this. This sign right here tells me that it's also equal to, having that little line underneath says that it could be partially equal to that. So somebody could be 40 inches to ride the roller coaster, or they could be 60 inches or whatever else, but they have to be at least 40 inches tall. So they have to be taller than 3 feet 4 inches, or they have to be as tall as 3 feet 4 inches to ride this roller coaster. Okay, so we're going to do a little bit of magic just like we did in the last video. Just hold on, alakazam. Okay, so the next part of this concept is to really understand when you're going to write what symbol. So if we're looking at the less than stuff, we essentially have less than words that we can remember are the words less than and then fewer than. And for that symbol, we have essentially a Pac-Man that wants to chomp things to the right side. The next one is the greater than symbol, and it wants to chomp things to the left-hand side. And words for that could be is greater than, is more than, and exceeds. So that means for both of these, we are omitting, if we were to say something is less than 12, so let's say the amount of weight I have gained in a year is less than 12 pounds, we could say we're going to have a less than symbol. So we're going to have a less than symbol, something that's chomping to the right. And so the amount of weight I have gained would be 12. Well, less than 12 pounds. So the 12 is next to the chomping sign because that 12 is bigger than the actual weight that I have gained. That is totally not the facts, but at the same time, that's kind of fun. You guys can all say I'm fat now. That's fun. All right, and then we have for less than or equal to. Oh, I just wrote less than. This should say less than or equal to. And the same with this. Actually, I'll rewrite that all together because that's just horrible. Less than or equal to. I'm going to do that same thing here, or equal to. Awesome. So for the less than or equal to, we have a chomper that goes to the right. Some other words for that is no more or is at most. And this last one, greater than or equal to, we can also hear, or you might also see words like is no less or is at least. That means that base mark is also included in that inequality. So here we go. A student must have at least 10 hours of instructor-assisted driving time to pass the course. Write an inequality to describe this situation. So let's get the important information. We're circling 10 hours. We know that we need that information, and it says at least. That's important. So a student, we're going to say a student, and we have 10 hours. And we need to show at least. So if we look for the words at least, I see at least being this sign. So that student needs to have at least, so greater than or equal to 10 hours. So essentially 10 hours would satisfy this, but so would 20 hours, and so would 15 and a half, or so would 10.25 hours. It doesn't matter, but they need to have at least 10 hours of driving time. Okay, so here is the next step of what we're going to be doing with inequalities. We need to decide sometimes whether certain inequalities are true or false. So I'm going to give us a scenario. We have the situation 3 plus x is less than or equal to 12. And what if x was equal to 6? So our inequality 3 plus x is less than or equal to 12, and x is equal to 6. So if we were going to put this information into this equation, we need to see if it ends up giving us a true statement or a false statement. So 3 plus 6 is less than or equal to 12. 3 plus 6, if we were to do that math, we get 9. Is 9 less than or equal to 12? Yes. I sure hope you know that. Yes, 9 is less than 12, and 9 is definitely less than or equal to 12. So there is one example. Let's try one more. Let's do this one. Y minus 7 is less than 10. And what if y was equal to 17? Let's see if this one works out. So y, we know that y is equal to 17, so we're going to put that into this equation. So 17 minus 7 is less than 10. 17 minus 7, we can do that math, that is 10, is less than 10. Now this seemed almost like a true statement, and if there were an equals to symbol underneath, then this would be totally a true statement, but unfortunately there's not. So therefore this is false. This statement doesn't work. And we've got two more little parts to this, and it's all about graphs. I hope we can do this I hope we can do this sort of evaluating inequalities. And now let's look at this concept. So we're going to look at graphing things. We're going to use a number line to do so. So first of all, I'm going to make a number line, and I want you to look at how I make this number line. First of all, we have arrow ends, because number lines do not stop at any point in time. They go to infinity, positive and negative infinity. And then next, I'm going to make tally marks. And I'm going to make these tally marks as evenly spaced as I possibly can. Because we are 8th graders, we can handle making evenly spaced tally marks. Now, no, they're not perfect. I understand that. But at least my graph doesn't look like this. Okay, do you see the difference? Yes. Bad graph. Okay graph. Bad graph. Okay graph. Do we get that? I think we do. That's awesome. So now let's restart. We're going to look at this. So we've made our graph. I'm just going to erase all this. We've made our graph, and now we are going to create an inequality. We're going to graph an inequality. So here's our inequality that we're going to graph. We have x is less than 5. X is less than 5. So what that tells me is I need to now label my graph. I need to give it some units. I'm going to make 5 be right in the middle. Might as well make it easy on myself. I'm going to add a 4, a 3, a 2, and I'm going to add a 6, a 7, and an 8. Okay, gives me some context. Next, this is the tough part. If I have an inequality sign that is just like this or like this, there is no equal to, we essentially have a less than and a greater than equal sign. The way we demonstrate that is with an open circle around that number. Now, if I have a less than or equal to, or less than and equal to and greater than or equal to sign, we can show that with a closed circle or filled in circle. This is the tough part. I want you to write this down as notes because it's going to be very important. So we are now going to graph this, and we're going to graph this at 5. We're going to do an open circle, a circle that is not filled in because this less than sign does not have an equal to number. And then from there, I'm going to decide everything less than x is going, or less than 5 is going to work for this. So 4 would solve this, 3 would solve this, 2 would solve this, but 6, 7, and 8, they would not solve this. So I have completed my graph by drawing a line to the right. Let's try a couple more, okay? So I'm going to leave this information here so we can see it. And here is a number line. I'm actually going to draw a couple of them because we're going to try a couple of different problems. So our first problem is x is greater than -2. And our second problem is x is greater than 0. All right, so looking at x is greater than -2. Let's put some tally marks on here, and I'm going to try to make them as evenly spaced as I possibly can. And in all reality, we don't need to have 20 tally marks. We could make it nice and big spaces and have it awesome and be just like that. It doesn't matter. So I put some tally marks on my top graph. Let's look at that first. We have x is greater than or equal to -2. Looking at this, I can see that my inequality is a greater than or equal to. That tells me I'm going to have a closed circle. I'm going to have a filled in circle. And I need to now label my graph. I'm going to put my -2 here. -1, 0, 1, 2. And I'm going to add -3, -4, -5. I think that's all I'm going to add. There's no need to put anything more. I'm going to find that -2, and I'm going to start out with an open circle, but I know I'm going to fill it in because this is an equal to. That means essentially if I were to put -2 into this equation, if I said -2 is greater than or equal to -2, that works. That is a true statement. So this -2 is part of that graph. Then next, what other numbers could work for that? Could I put a -1 in here? Would that work? Is -1 greater than or equal to -2? Yes. So I am going to draw an arrow to the right. If I were to also check this for -3 is greater than or equal to -2, no, that does not work. That is an incorrect statement. So I'm not going to be shading anything to the right, or to the left-hand side. Now let's look at this next one. We have x is greater than 0. Here is our inequality. Looking at that, here is our sign because there's no equal to underneath it. There's not a straight line underneath it. We have x is greater than 0, so it's going to be a open circle. I'm going to put some context to my graph by adding a couple of numbers. We have -2, -1, 0, 1, 2. I'm going to add my open circle. And now I'm going to decide, okay, if I were to put 1 in this situation, is 1 greater than 0? Yes. Now, is -1 greater than 0? No. So I know I'm going to shade in the positive direction. Now that is the remainder of this section. Thanks for listening.